Hello everyone, welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and we are once more in preparation mode for our 2024 exams coming up. Of course, we are in the crucial stage of our preparation. Most students would have completed more than half or a little bit more than half of the syllabus, and we are currently in motion being prepared for the exam, which is about 2.5 months from now upon making this video. Now in today's tutorial, I'm going to be walking you through yet again another assessment paper here that I recently gave a group of 200 plus students. We have so far completed topics. We are in the latter phase of algebra. We have completed the topic of transformation geometry. We have covered fundamental concepts such as variation, consumer arithmetic, worded problems, and factorization, and also coordinate geometry. So in this particular tutorial, what you're going to be seeing here is a review of the solutions to that paper. Of course, this would have been a similar paper that I had posted just a few days ago, about a week ago. So you can definitely check out that particular review as well. It was in fact very similar to this one. There are a few questions that are on this paper that were on that paper as well. So I'm going to be walking you through this particular paper here so that we can, of course, go forward and apply the concepts a bit later to improve our current grades. Of course, the grades so far from this paper are not looking so pleasing, but there is still work to be done, and of course all my students have potential, and of course also here you guys must be on this channel because you are also in preparation mode. So before we jump into the tutorial for today, do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments down, guys. I'd love to hear your thoughts. Have any questions, feel free to leave them down in the comment section. Be sure to click in the description box. You're going to find information regarding my channel, my social media handles, and of course information to how you can become a part of my live sessions outside of YouTube. All right, so without further ado, let's jump right into the video. And again, do not forget to hit the like button, guys. It really does help the channel to grow. So let's get into this practice mode here, and we're gonna be getting in mathematical mode right now. So let's go, guys. Here we go. So of course, I currently work for an institution, but I also have my platform here, and of course this exam was given to students on February 12, 2024, and the instructions are as follows: that you should answer all questions and show all working where necessary to attain full marks. All right, and so for question 1, we are asked to evaluate and express as a single fraction 2¼ multiplied by 4/5 all divided by 3/5 minus 1/2. So to approach this particular question, we're therefore going to be doing this question in parts. We're going to be working out the top section first, then we're going to be working out the bottom section next, and then we're going to be dividing the answer that was calculated at the top by the answer that was calculated at the bottom. So I already have this question drawn up on screen here for you. So we're going to proceed here to work out the top section here. So at the top section, we have a mixed fraction of 2¼ so that's going to be 4 multiplied by 2 is 8 plus 1 is 9/4, and that's going to be multiplied by 4/5. Now the rules for multiplication of fractions is that we're going to always look for a number that can cancel both numerators and denominators. So in this case here, it's very easy that 4 into itself one time and 4 into 4 one time. So therefore then we have a reduced fraction here of 9 times 1 is equal to 9, and say here 1 times 5 is equal to 5. So therefore then what we have here is 9 over 5 for the answer at the top. We're then going to be proceeding now to work out the fraction at the bottom, and so the fraction at the bottom here is 3 over 5 take away 1 over 2. And so once we're dividing or adding fractions, the rule is that we're going to be finding the LCM. So the LCM of 5 and 2 here is 10. So 5 into 10 goes 2 times, and 2 into 10 goes, say here, 5 times. 3 times 2 is equal to 6. Take away 1 times 5 is equal to 5. Therefore, the answer for the bottom here is 1 over 10. So we have two solutions here. A solution of 9 over 5 for the top fraction, and we have 1 over 10 for the bottom fraction. So this means then that we're going to be taking the answer that we got for the top, which is going to be 9 over 5, and that's going to be divided by the answer that we got at the bottom, which is 1 over 10. So therefore then easily then 9 over 5 is then going to, instead of dividing, we're going to multiply by the reciprocal of 1 over 10, which is in fact 10. So therefore then that's going to be 10 over 1. We're going to say 5 into itself one time and 5 into 10 2. Therefore easily our final result here is 9 times 2 is 18. If you want to write 18 over 1, that's also fine as well. But 18 over 1 is in fact 18. And this then gives us our final result here for question 1. Alright, let's go then back to the exam paper here. So we have an answer here of, finally then, 18. Next then, we have AII, correct to 3 significant figures, values of 18.75 minus 0.11 squared multiplied by the square root of 9.5. Now I've already got my calculator here in hand. Alright, just a second here guys, let me get this calculator charging. Now I have my calculator in hand here. What I'm going to be looking at is using the order of operations. Many students get caught when they get simple questions like this, yet so simple, but yet if you break the rule of PEMDAS, you're going to find all your steps being reached a point, a futile point. So therefore then here we must remember the rule of PEMDAS, and I have a link that will be pinned in the description of, or also maybe you can find it pinned in the comments section below. You're going to find a link to that video where you can actually work on your fundamentals of using the PEMDAS rule. So here we have subtraction, we have an exponent, we have multiplication, and we also have here a root symbol. So this simply means then, let's just take you to a fresh page here, and then we're going to be looking at, see here, PEMDAS. So therefore then there is no brackets here, right? So we know that for P, E, M, D, A, S, there are no parentheses working with here. Next then we're going to be looking at the exponent section, if there is any. So there is in fact an exponent of 18.75. There's an exponent of 0.11 squared. So that's going to give us 0.11 squared, and that gives us a result of 0.0121. So that is 0.0121. And then of course the square root is in fact going to be also an exponent as well. So because the square root of a number is in fact the number raised to the power of a half. So we in fact here have the square root of, say here, 9.5, and so that results to be 3.08. So that's 3.08. Now, here is where many students make the mistake. They go ahead and they just work the math from left to right, not recognizing that PEMDAS is still in play. Next, then you'll see that M must be done after exponent. So there's an M in the expression here. We have 18.75. Take away the result of this multiplication over here. Then I'm going to multiply that by 0.0121. So I'm going to end up with 0.037. So that's 0.037. So you must multiply before you subtract. Many of my students made a huge error in subtracting before they multiply. And then so finally then we're going to be simply subtracting then say here 18.75 take away 0.037, and so we end up with 18.71. So our final result here is 18.71, and they set to 3 significant figures. That's going to be in fact 18.7. That is 3 significant figures. All right, so that pretty much, this is how you're going to approach the question, ladies and gentlemen. You want to approach the question from a fundamental perspective. Do not just rush to do the problem. You must follow the laws that were given to you in lessons in the past. All right, so now that we have gotten very comfortable with the first 2 questions, let's then move on to say here question 2. And this is a worded problem. All right, and let's get to reading here. It says that a dining room suite is currently on sale and has a marked price of $56,000. If a customer decides to pay cash, they would be offered a discount of 18%. However, if they are unable to do so, they can acquire the suite on a higher purchase deal by making a deposit of 30% down and 1.5 years of equal monthly installments of $2,800. The questions here are, in fact, A. 2 customers walked in the store taking separate deals. How much more did the customer saved by paying cash? Let's attack this question from the top. Let's break it down from the top. Now, you want to start off your calculation line by line, paragraph by paragraph, so to speak. So here we're looking at the fact that the actual cost of the suite is $56,000. Now, if, say for example, I am customer 1, if I walk into the store and I wanted to buy this particular dining room suite here cash, then the company is going to offer me an 18% discount. That means I'm going to be paying less than what is being advertised. So let's go ahead then and go for that question here. We're going to go ahead then and we're going to find here that we're going to find 18% over 100 multiplied by 56,000. This would then tell me how much I'm going to be subtracting from the 56,000. So that's 18 divided by 100 multiplied by 56,000, and that gives me $10,080. So therefore that is $10,080. That is the amount that's going to be subtracted, so that the customer paying cash, that's what they are going to pay. So therefore this is going to be 56,000 minus $10,080, and that's equal to 40, say here 5,000, I think 920. Yes, that is correct, $45,920. So this is what the customer that is paying cash would actually pay to the clerk at the counter. All right, now that doesn't answer the main question. That is just a part of our calculation. Let's continue reading then. It says that if a customer decides, however, if the customer is unable to pay cash, they can still get the item. However, the deal is that they are going to have to make a 30% deposit that is in fact 30% of the advertised price, and then for the next 1.5 years, each month equally they're going to be paying $2,800. Now there is in fact a hire purchase formula, but let us just say hypothetically that we did not know that a formula exists. We therefore would have to calculate what is this deposit that is going to be paid down. So the deposit therefore then is going to be, let's see here, the deposit then is going to be equal to 30% of the original. So that's 30% of 56,000. And so therefore that works out to be 30 divided by 100 multiplied by 56,000. That is $16,800. And so therefore that's the deposit. Now after making that deposit for the next for the next 1.5 years, there's going to be equal monthly installments of $2,800. So we therefore need to calculate how much months make 1.5 years. Now we know that 12 months is equal to 1 year, and 1.5 years, half a year is 6 months. So that's therefore 12 months plus 6 months. That is 18 months where the customer is paying $2,800 each. So therefore then that's going to be 18 multiplied by $2,800, and that's $50,400. So over the course of the next 1.5 years, the customer would have actually paid $50,400 in installment, plus remember the initial deposit that was paid down. $. Then you're gonna find then finally that after 1.5 years, the customer that took the higher purchase deal would have actually say here paid, pardon me, here, so that's 50,400 plus 16,800, and so the customer would have actually paid over the course of the next 1.5 years 67,200. So we have a bunch of calculations here. Let's just go back to what the question asks us, since we have utilized all the info provided. It says that customers basically walked in the store, they're taking separate deals. That means one is taking the cash deal and one is taking the hire purchase deal. The question is, how much more did the customer saved by paying cash? That's a very ambiguous question, because I find that many of my students were asking me interpretation of this question. This question was written in such a way that it could all how much did the actual customer that paid cash saved, but in fact what I was trying to get the students to calculate was how much more did the customer that paid cash paid more than if they had taken out the higher purchase deal. So that's what we needed to calculate. So therefore then, remember that we already calculated that the customer paying cash paid $45,920, and the customer paying higher purchase paid $67,200. So these two numbers are going to be crucial to answering that question, because we are therefore going to go ahead then and subtract, say here, $45,920 from $67,200. And so therefore the answer that I was looking for, based on how I wrote the question, was going to be, say here, 67,200 minus 45,920. The customer that decided to take cash would have saved $21,280 more if they paid cash as opposed to taking out the higher purchase deal. And that is basically the solution to the question. So it took a bit of thinking, which is why this is called a CSEC preparation tutorial. because of course, this is what CSEC wants the students to do. You have to be able to show your knowledge and your application and your reasoning skills when you're solving these questions. All right, so I do hope that you students got some clarity on that. So going forward, understanding the question is going to be key. Now, part B here says that the customer that paid cash decided to resell the suite to make a profit of 30% on her money. So how much did she sell the suite for? So obviously the customer paid $45,000 because of course the deal was that if she paid cash, she'd pay 18% less than the original. So therefore she basically has spent $45,920. Now she wants to sell the item to make a profit of 30%. So there's two ways you can actually work this out. All right. You can actually go ahead then and say here that 30% over 100 multiplied by 45,920. And so when you get that answer, you're going to add it back to 45,920. And so therefore, let's get to that. It's going to be 30% divided by 100 multiplied by 45,920. And that gives 13,776. So that's 13,776. Therefore, when we add that 13,776 after selling this dining room suite back to someone else, then therefore the answer there would have been 45,920 plus 13,776. So this customer here would have made $59,000, $59,696. So they would have gotten back their money that they spent and a little bit of profit, which is equivalent to 30%. We could actually get that 59,696 simply by just adding the 30 to 100 and then dividing it by 100 and multiplying it by 45,920. And it would have just given you directly here the answer of $59,696. All right, so that is how you would answer that question. Do not forget to hit the like button, guys, if you're getting some sort of value from the video so far. If you've finally gotten clarity, if your understanding of how to interpret the questions are getting better by the second, by the minute, and as this video goes on, do not forget to hit the like button. It really does help the channel to grow and to reach a wider audience. All right, let's then jump on to our next question. We're going to be going down to the algebra section of the paper, and this challenged a lot of my students based on the papers that I have marked so far, and I'm not so sure why, because of course each of these factorization techniques can be identified by a very specific value in the equation. A quadratic equation has a certain look, grouping has a certain look, difference of two squares has a certain look, 8CF method has a certain look. So all you guys had to do was to determine which one of the factoring techniques would be required to solve each of these, to simplify each of these questions. And of course, if you do not know the individual factoring techniques and you have not put any practice in on each technique, then you're going to find a lot of challenge in this. Many of my students I find complained a lot about remembering the formula. Remember, memorization is temporary. Practice gives permanent retention. All right, so you've got to practice, guys. If you're not practicing, you're going to consistently have the same challenge. Let's get right into it here. We have 32x squared minus 200. Now we must determine what kind of factoring technique is required for this question. Now, when you look at this question, you have two terms and it says factorize, and so I've emphasized many times over that the verb factorize means that we're looking for a common factor. All right, at all times we're looking for a common factor. So here we're looking at what is common between 32x squared and 200. Now if you look at it carefully, it looks like 2 could possibly be the highest common factor, but if you know your timetable very well, you'd recognize here that 4 could also be used, but there's also a bigger number, 8 here. So we could factor out 8 as our common factor here. And so what is going to be left then is going to be 8 into 32 goes 4 along with the x squared. So 8 into 32 x squared goes 4x times. And so 8 into 200 so happens to go 25 times. Now you have to be able to recognize, guys, whenever the factorization is complete or not. And so if you look carefully at this question here, you'll see that this expression inside here is what is known as a difference of two squares. Now, how do we generally recognize a difference of two squares? Is that we know that the numbers that are there are very familiar. We know numbers like the square numbers 1, 4, 9, 16, 25, 36, 49, 81, 100, 121, 144, 196, 225, 256, 289, 400, 441, 484, 529, 625. These numbers are very special numbers, and usually when you find any combination of those numbers that I've just listed from 1 to 25, you're going to find here that it tends to form what is known as a difference of two squares. So therefore then what you're looking at here is in fact the 8 here on the outside, and notice then that 4 is actually going to be 2 squared, and so x is also squared. And then of course you'll recognize here that 25 is a special number that is also 5 squared. Now it's a difference of 2 squares, so therefore what that means is that we have to find a way to find the value that is going to convert all of these terms all raised to a power of 2. Once we're successful in getting that done, then the rule is that we're going to be opening up 2 pairs of brackets, and we're going to be having plus in one bracket and we're going to having minus in the other bracket here. And so 2 squared means 2 is going to be on here, and 2 is going to be on here, on that side and on that side. And then we're going to have also say here we're going to also have here x, because we have x squared, so x is on here and x is on here. And so we're going to have plus in one bracket and minus in the other bracket, and then we have 5 squared and 5 here. All right, now I do not have a video on perfect squares or difference of two squares as yet, but when we get to that level, we're going to see tutorials on that particular topic. But for now, let us be prematurely exposed to this here. But many of my students who are currently watching this video would have already gone through this topic of difference of two squares. So this then represents our final result. That is in fact 8 open bracket 2x plus 5 close bracket open bracket 2x minus 5, and that completes our factorization for that question. Now if we scroll on down here to now factorization number 2, this is a very, very familiar situation here. This is factorization by grouping. And so with factorization by grouping, what we're looking for is trying to get the terms in pairs of 2. But when we are pairing them, when we are grouping them, we have to ensure that we either group them by coefficients or we group them by a specific variable. In this case here, I can actually group them by p's. So I'm going to put a bracket here and a bracket here. And then I'm also going to be grouping these 2 over here by q's, all right, over here and over here. Now in this bracket here, we're going to be factoring the 2 blue brackets separately, and in the next line we should automatically end up with 2 things in the same bracket here. So then we end up here with the common factor of 6 and 9 is the highest common factor is going to be 3, and so p is also a repeated variable, so therefore p is also a common factor. Now open a bracket here, 3 into 6 goes 2 times, and so p into p goes 1 times. Basically we normally say p cancels p. Let's go over here, we see 3 into 9 goes, say here, 3 times, and so p will cancel p, leaving us with s here, and close the bracket then. Now on this side here, we end up here now with, say here, common factor here of -2. And so we're going to open our brackets here. Oh, there's another common factor, 2. And we're going to be taking out also q. Q repeats itself. Now by opening the bracket here, -2 goes into -6 3 times. And q cancel q, leaving us with s. And over the second term here, -2 divides into +4, goes -2 times. And so q cancel q, closing the bracket here. Now we have a problem. Can you identify the problem that we're having? The problem is that these two brackets are not the same. And for factorization to continue, the two brackets must be the same. Now we've done everything right. So what would have been the catalyst in causing these two brackets to be different? Now, usually when this situation occurs, what you're looking at is that we need to shift up the terms. So we could actually go ahead then and put the -9ps in front of the 6p, so that the term inside the bracket, or the expression inside the bracket, could become like the one in the bracket over here. Or we could go ahead and put the 4q in front of the -6qs, and when we factor, then this bracket over here is going to look exactly like the one over here. So I do recommend that when you reach to this level, if you want to start over, you can go ahead and start over by just shifting up, say here, any of the two terms in the expression. Or what you can do, you can use a cheeky little method here. Here's the cheeky method. Here I factorized 2. Now if I had factorized +2 instead, then you'll recognize here that +2 into -6 goes -3 times. And so +2 into +4 goes +2 times. And so it still seems as if the brackets are in fact varied, but they're not. Because if I just take +2 here and put it in front of the -3, I'll now end up with the same thing in the bracket. So that's just a cheeky little way there of getting back in line with what the question requires. As opposed to factoring out a negative number, you can factor out the positive form of that number and turn your term around based on what you're seeing. Alright, that method was also explained in a previous video about how to turn around variables when you're factorizing out negative and positive numbers. Do check that video out. You'll find that technique quite useful. Now we end up with the two same things in the bracket then. What we're looking at then is in fact 2 minus 3s as the common factor. And so because they are repeating itself, they are now the common factor. Therefore, what is left then is 3p plus 2q. And that is your final result. All right. So the more you practice is the more you're going to have a little bit of confidence in being cheeky when you want to get to your result. Remember that you must factorize mathematically. You cannot cheat. We are going to catch you. All right. You cannot cheat or try to write down the answer based on what you feel. There has to be a mathematical approach to this. All right. Beautiful. Let's move on then to the third and final factorization question. Now this expression here is very familiar because in fact most of my older subscribers would have seen my first video that I placed on this channel here, how to factorize a quadratic expression. And so a quadratic expression here literally is identified by the mere fact that there is a squared term here, and of course there's always 3 terms that make up the expression. So this is a quadratic because it is written in the form ax squared plus or minus bx plus or minus c. And so once we see that, we can therefore then go ahead and use the AC method. So what's the AC method here? The AC method here is that we're going to be multiplying the first term by the last term. So that's going to be 2 multiplied by minus 30. And that's equal to minus 60. And then of course you're looking for groups of terms, pairs of terms, pairs of factors that will then multiply to produce negative 60, but at the same time it will therefore add or subtract to produce the middle term here, which is in fact positive 11. That's our aim. So therefore then we're looking at, say, 1 times 60 is a possible pair. 2 times 30 is also a possible pair. 3 times 20 is a possible pair. 4 times 15 is a possible pair. 5 times 12 is a possible pair. And 6 times 10 is a possible pair. So all of those pairs multiply to give potentially negative 60, but only one will be able to produce positive 11. Now, I'm almost certain by logical reasoning here, there's no way 1 and 60 could produce 11. There's no way 2 and 30 in any way, shape, or form could produce 11. I'm also certain that 3 and 20 cannot produce 11. I'm almost certain then that 5 and 12 cannot produce 11. And of course, then you'll see that 6 and 10 cannot produce 11. So therefore, the only possible pair here is 4 and 15. But how exactly would we get 11 using 4 and 15? Obviously, the larger of the two pairs is always going to take the sign of the middle term here. So right away, I know that this is going to be positive 15. And then I know that, of course, to get 11, I'm going to have to subtract 4. You notice that 15 take away 4 is going to be 11. And at the same time, 15 multiplied by negative 4 gives negative 60. So I know then for sure that I have chosen the correct pairs of factors. Now, once we have successfully, we are therefore then looking at saying here 2x squared. And we're going to take these two terms that we have chosen here and place them in the middle, replacing the 11x. So that's going to be 15x, take away 4x, take away 30. Now, many of my students have asked, does it matter if I put the negative 4x in front of the 15 or the 15 after the 4x? You're always going to find a common factor once you group like terms. And so you notice that the importance of having that grouping technique packed down is going to be crucial to finishing this question then. So therefore then we're looking at the first bracket. What is the common term or numerical value? There's nothing common between 2 and 15, but there's a common factor of, say here, x. Now of course, x divides into 2x squared 2x times. And x divides into 15x. Obviously, the x cancels the x. So we're left with 15 here. And so again, I'm going to just write down my minus here. And the common factor, the highest number that can go into 4 and into 30 seems to be 2. And so I'm going to open the bracket here and say 2 into 4 goes 2 times along with this. And bear in mind that negative 2 into negative 30 goes 15 times. Once again, we are successful in getting the same things in the bracket, even without being a little bit cheeky. So therefore, then we end up with 2x plus 15 as our common factor, and then so forth. What is left is then x take away 2. And that is how you factorize a quadratic expression. To get a more complete breakdown of this particular topic, please visit the algebra playlist in my video description or pinned there in the comments, and you can check out how to factorize any and every quadratic expression, even with very large numbers and very small numbers. All right, beautiful. So then next, we have completed the factorization part of our paper. Do not forget to hit the like button. Let's jump on to part B here. We're going to be simplifying this particular algebraic fraction, as well as we're going to be we're going to be rearranging this particular equation here. So therefore then, what we're looking at then is, in fact, say here, 3x minus 4 over 3 take away 2x minus 5 over 4. This is a very simple question, but I did find in my analysis whilst marking the papers, I find that many students are still finding this topic a challenge. I think that from my perspective, I think that many students over the years who have struggled with CSEC and struggled with topics like these is because of the fact that they are memorizing more than they are practicing. They're trying to remember what to do as opposed to knowing exactly what to do. Now here, an algebraic fraction is no different from that of a numerical fraction. If you're adding and you're subtracting a fraction, then you're of course required to find the LCM, which in this case here is 12. That is in fact 3 times 4 is 12. Now, what I find that many students do here is that they get to the point where they say 3 into 12, and they do this thing here where they put times 4 here, and they put times 4 here, and then they also put 4 into itself here, goes 3 times, they put times 3 here, and they put times 3 here. Now, whilst that works, all right, you've got to understand that signs are going to somehow play an important role. So you're going to end up with, say here, if you do this and you don't know exactly what you're doing, you will find that your answer at the end, your steps, your process would have been perfectly correct, but your answer is going to be a little bit off. Now, I really do not recommend doing this, especially if you're fundamental or you're just learning this for the first time. What I do recommend though is that you go ahead then and you say here 3 into 12 goes 4 times, and then you open the bracket and put 3x minus 4. You just bring down the numerator onto the line. You also say 4 into 12 here, bring down the minus here, so 4 into 12 goes 3 times. Basically, we're saying negative 4 into 12 goes negative 3 times. Open the bracket, 2x minus 5. Now, what's the difference between opening the bracket and putting the multiplication sign here? Many students I find also, when they say 3 into 12, they say it goes 4 times. They sometimes multiply here by 4 and forget to multiply this term by 4. And they also say 4 into 12 goes 3 times. They'll multiply this number by 3, this term by 3, but they forget to multiply that number by 3. And this is me speaking from experience. I'm seeing this year after year. And so I'm hoping that this particular tutorial is going to finally give you the clarity that you need. Please do not use that method. It tends to throw off students a lot. Now, whilst I say put these into a bracket, whenever you're dealing with a binomial expression and multiplication is involved, it is highly recommended that you use brackets. So this means then that 4 is going to multiply the 3x, but also say here the 4 has to multiply the minus 4. Minus 3 will then multiply 2x, and so minus 3 will multiply minus 5. So therefore then what we're looking at then is 4 multiplied by 3x is in fact 12x, and so 4 multiplied by minus 4 is minus 16. Minus 3 then, here's this minus that's going to affect what is in the bracket. Minus 3 multiplied by 2x is minus 6x. And so if you had used the previous method and you do not know what you're doing, you might end up, say here, as opposed to having minus 3 times minus 5 positive 15, you're going to end up with, say here, minus 15. And it is going to be all over 12. So you've got to know what you're doing if you're going to use a particular method. Since you find it easier, make certain that you know the pros and cons of that method. So therefore, we're going to be grouping like terms. You're at an advanced level, so you should be able to see that 12x take away 6x is in fact 6x. And so negative 16 plus 15 is minus 1. If you had used the previous method, you would have find yourself ending up with minus 31 or some other number. And then this is going to be all over 12. And then this here represents the simplified version for our expression here. All right. So if you did in fact get this answer correct on your first attempt, leave your thoughts in the comment section below. And if not, of course, I do hope that you learned then what to do the next time. Let's look then at rearranging this equation. I believe that the instruction was that we should express t in terms of v and x. Let's just confirm that. The instruction is in fact that we should express x in terms of t and v. And so I recently posted a video. In fact, I just posted the video as it relates to this very particular topic here. And so for this particular topic here, we were looking at transposition of equation. You'll see a link popping up in the top right hand corner. Feel free to click on that link and watch that video. So here now we're looking at expressing, say here, x in terms of v and t. And in terms of v and t means that v and t should be a part of your answer and x should be the subject. Now in this case here, you're going to find here that cross multiplication is going to be your best source of start here. So then we're going to be cross multiplying. Let's just write some instruction here for you. So we're going to cross multiply simply by putting the v over 1 here and multiplying the v by that binomial expression at the bottom, and then multiplying the 1 also by that binomial expression at the top. Now bear in mind that once it's binomial, remember that whatever you're using to multiply the first term must also be used to multiply the second term. We just looked at that moments ago. So therefore this is going to become, let me just write it down instead. Okay, so we're going to have this v here, and we're going to open a bracket here, t plus x. You can skip this line if you want, guys, if you're at an advanced level. And so this is going to be equal to, of course, the multiplication by 1 identity. Once you multiply anything at all by 1, you're going to get that same exact thing. So that's t minus x. So you can skip this line here by simply jumping ahead and say v times t here is in fact vt. And of course, do not forget to use the v to multiply the x, so you end up with, say here, vx. Please bear in mind that the objective of this equation is to make x the subject of the formula. So if x is required to be the subject of the formula, then it simply means that I need to group like terms, and I need to group the x's together and of course any other term on the other side. So I already have a vx on the left. I'm just therefore going to transpose here this negative x here. So I'm going to transpose this negative x right in front here. So that's vx, take away x. And that's going to be equal to, say here, I did not touch the t, so the t remains as t. And so obviously I'm going to have to move this vt here all over this side here. So that's going to be negative vt. Now I have a more organized equation. Now I'm unable to subtract x from vx because, of course, in algebra the fundamental rule is that we cannot subtract unlike terms. In this case here, we're going to go ahead and we're going to factorize. So we're going to factorize the x out. So we're going to be factoring, say here, the common factor here is x. And so that's going to be equal to x into vx goes v times, and x divides into x goes 1 times. So that's factorize x into vx, v times x into x goes 1 times, 1 time. And so therefore that's going to be equal to t minus vt. Now that I only have x and the binomial expression v minus 1, I can simply divide both sides of the equation by v minus 1. And so that's going to be equal to, of course, t minus vt divide also by v minus 1. We spoke about that in our video tutorial. We have to balance the equation by dividing both sides by the unwanted term or expression. So therefore then finally then to get to our answer, v minus 1 cancel v minus 1. Therefore then our final result for x in terms of t and v is that x is equal to t minus vt all over v minus 1. Awesome job. So that brings us to our answer for that particular question. All right, once you know your rules, guys, you have to make sure that you practice until it becomes second nature. Let's move on to solving this inequality here. And oh my word, did all of my students made a mess of this question. This was particularly one of the most detailed video that I had created for you guys. I'm not sure if you might have attempted the question a little bit, or you had watched the video a little bit too late before the exam, but I didn't see any of my students really applying the methods that I showed in my previous tutorial. Do definitely take the time out, guys, to check out the tutorial on fractional equation. I believe you'll find this particular solution and explanation in part 3 of that video. So do check the description box below for that particular video. But here, very simple, guys, as had discussed in that tutorial video. Once you have a denominator, the aim is to eliminate the denominator first. I find that many students were trying to group like terms, like pushing the fraction over here and working out the fraction and then dividing by -2. All of that is just a rigmarole. It's just too much work. It's so much easier here to find the LCM, which is in fact, say here 20. That's 5 times 4, so that's 20. And so, of course, as I mentioned before, we're going to be taking the equation here and we're going to be multiplying every single term in the equation here by 20. So therefore then what we're looking at then is in fact 20 multiplied by 3 over 5 minus 20 multiplied by 2x, that's less than or equal to 20 multiplied by 7 over 4. And so therefore that's going to be minus 20 multiplied by, say here, 5. And this is the way you do it, guys. It's very simple. So then what happens then is that we're going to be going ahead then and cancel the 5 with the 20. We end up with 4 times. And we're going to cancel the 4 with the 20. We end up with, say here, 5 times. And so just to get a straight line equation or a very straightforward equation, we end up with 4 multiplied by 3 is 12. 20 multiplied by 2x is negative 40x. So that's negative 20 multiplied by 2x is negative 40x. And that's less than or equal to 5 times 7 is in fact 35. And of course minus 20 times 5 is 100. So now easily then we know that we can either choose to keep our subject negative or have our subject. We can decide to have a negative subject, but bear in mind that if you're going to be dividing the equation by a negative coefficient, we have to reverse the sign. or we can so simply try to transpose the subject so it can become positive. Now in this case here, I'm just going to go against what I would normally do because I'm very concentrated. I'm in practice mode. I'm feeling very confident in my ability and I know the rules. So I find it more challenging to bring over the 35 and the 100 and then bring over the negative 40x, as opposed to simply just focusing here, bringing over the 12 on this side here. And so we're going to end up with negative 40x is less than or equal to 35. Take away 100. And of course, positive 12 becomes minus 12. So therefore, then we can go ahead then and say here, work this out. So we're going to end up with, say here, whoops, pardon me, negative 40x is less than or equal to 35, take away 100 is negative 65, and negative 65 minus 12 is negative 77. So then easily then we can split the product by dividing both sides by negative 40, bearing in mind that this is an inequality. So we're going to end up with then say here, x is, as opposed to being less than or equal to, is going to be greater than or equal to, when I divide negative 77 by negative 40, I'm going to get positive 77 over 40. And I don't need to really convert that to a decimal. I think that the fraction is more than accepted. All right. And that is how you'd solve that very simple linear fractional equation. All right. So next time, guys, as I said, once you see this question, you need to remember this approach. And of course, you need to practice this approach. You're going to find it quite useful in the future. All right, we're almost up on an hour into the paper. And remember that, of course, this video is primarily geared towards giving students the ultimate preparation, giving you guys the guide, the thought process to build your analytical skills when it comes to these questions. It's not about rushing through the paper. It's ensuring that you guys understand the question in full details. All right. So here then, when we're looking at question 4, I had a typo error here because we just did question 3 down here. This was question 2. This was supposed to be question 3. And then obviously this is supposed to be up here, say question 4. Nevertheless, let's look at the question then. Now we're looking at transformation, and it says here that the points A, 2, 3, B, negative 3, 4, and C, 0, 1 forms the shape of a triangle. Your first task is to plot the following points and draw the triangle on the graph paper that was in fact given. Now I still found that many of my students are struggling. Many students, in fact, not just my students upon making this video, but many students are still struggling with plotting points. And again, right here you'll see a pop-up at the top right hand corner of a video to which you can get a full guide on not only plotting points, but you have a complete guide on the topic of coordinate geometry. Please feel free, guys, to check those tutorials out. I have went through every crevice and corner of coordinate geometry. So coordinate geometry is the topic that introduces how to plot points on a Cartesian coordinate system. So I'm just going to jump right into the whole plotting of the points, assuming that you guys remember that when you're plotting a point, the first number tells you the direction that you x-axis, and the second number here tells you the direction that you travel on the y. So let's go ahead then and look at our points that we have here. So on here, I'm required to plot the point 2, 3. So let's go ahead and find 2, 3. My scale is already labeled here for you guys. So I'm going to go ahead then and I'm going to use, say here, the black. Okay. So here we go. We're going to look at the first point, which is in fact 2, 3. So that's going to be 1, 2, that's positive 2 to my right, and 3 up. 1, 2, 3. And that's going to be the first point. I believe it was A. Then the next point that I'm going to have is going to be negative 3, 4. So that's going to be 1, 2, 3. That's negative 3 to the left and 4 up. 1, 2, 3, 4. That's the next point. That's B. So this is A. This is B. And so for C, I'm going to end up here with C being 0, 1. This was a problematic point. 0 means that I'm still at the origin here. 0 is the first movement, whether I go left or right. Now, if I'm at 0, obviously I cannot move. So 0, 1 means 0, which is the same starting position, and up 1 on the line here, right? And that's going to be my point, say here, C. And so, of course, they said that we should plot the point and draw the triangle. All right, let's double confirm on our points here. It is 2, 3, minus 3, 4, and 0, 1. All right, and go on our graph, and this is the particular shape that you guys should in fact end up with here. All right, should end up with a shape looking almost as good as this one. Haha. Now, since that is our shape, let's go back to our next question then to see what is it that they have requested of us after plotting the point. Part B says that the triangle undergoes 2 separate transformations, which is in fact a reflection across the x-axis followed by an enlargement of scale factor -2. Our task is to calculate the coordinates of the images, that is, of course, after the reflection as well as after the enlargement. And of course, you're going to draw them, which is draw both images on the graph sheet that was provided. Now, I do not have a tutorial video on transformation, so I'm going to have to walk you through a little. Remember that, of course, not everybody here that's watching this video was able to attempt the question. But okay, let's go ahead then and talk a little bit about reflection. So, based on the knowledge that I'm going to be providing in the future, that a reflection in the x-axis suggests basically then that if we have a point, let me write this down, reflection in the x-axis. This means then that if we have a point, say xy, any random point xy, and it is sent as a reflection across the x-axis, then you're going to find then that the x-coordinate is going, or the x-ordinate value is going to remain the same, but the y value is going to change. And so basically here, most of my students do not know this, but there is in fact what is known as a reflection matrix. And so basically the reflection matrix is basically asking yourself how many x and y's are at the top, and basically how many x and y's are at the bottom. So in this case here, I have 1x at the top, and I have 0y. Then I also have 0y at the 0x at the bottom, and -1y at the bottom. So therefore, this is my reflection matrix. Now, a lot of students are not able to remember the reflection matrix because, of course, when you start to learn the rotation matrix, the ones and the zeros and the zeros and the ones tend to be a little bit very confusing. So I do recommend that my students kind of focus mainly on, of course, knowing what happens to the points across the x-axis. And that is in fact that the x remains and the y changes. For the purpose of this video, we're not going to be talking about any other reflection, just particularly this one. And so therefore then all our points that we initially had then, which was in fact 2, 3, -3, 4, and 0, 1 will be sent through the x-axis. And so based on our theory then, is that 2, 3, the 2 is going to remain and the 3 is going to change. Then the -3 is going to change to 3. Pardon me, the -3 is going to remain as -3 and the 4 is going to change to -4. And of course 0 is going to remain as 0 and 1 is going to change as -1. And so basically these are our new points. First prime, B, second prime, and C. B, first prime, and C, first prime. These points are the points of the image after it has been reflected in the x-axis. Let's go ahead and plot those points. So that's 2, -3. Let's go ahead then, 2, -3. So that's going to be, say here, 2 to my right. So that's 1, 2, and 3 down instead. 1, 2, 3. That's going to be my A prime. My B prime is going to be 3, -3, down 4. So that's going to be 1, 2, 3 in this direction and down 4. 1, 2, 3, 4. And that's going to be my B first prime. And then C is going to be 0, -1. So once again, 0 is in the center here. That means I should not go left or right. But then I'm going to go down here. That's going to be, say, here. Okay. I'm going to go ahead then and use a different color here to represent this. So this is going to be here and here and here. That is basically the image after the object has been reflected in the x-axis. Now, alternatively, guys, we didn't have to necessarily say here know what happens in the x-axis, since as we are already graphically on the paper. Remember that a reflection, well, I shouldn't ask you to remember because there's no video on my channel regarding reflection, but please note that a reflection is basically where the object is mapped onto its image across a mirror line, which acts as the line that cuts the distance between the object and the image into two halves, or basically it's an equal overlap. So if you notice here that this red line here is the line of reflection, and notice that A is in fact 1, 2, 3 units towards that line. So my reflection is going to be the same at the bottom, 3 units below. 1, 2, 3. So we could have gotten A without the actual formula. Same thing here for C. C is 1 unit above, 1 unit below. And notice that B is in fact 1, 2, 3, 4 units above. So B is going to be 1, 2, 3, 4 units below. And then we could connect them and form the same shape. Alright, so if you know what you're doing, then that is no problem. But I do strongly recommend that you in fact go ahead and study what happens in each axis, the x, the y equal x, and the y equal -x. Now remember that this is after the first transformation. It then said followed by. Therefore then we are now going to enlarge the blue diagram here, the one at the bottom, or the one that you guys would have had in broken lines, by a scale factor of -2. So when it comes to then say here enlargement, okay, so let's just write that down for enlargement. Enlargement has a scalar matrix. Pardon me, it's basically a 2 by 2 matrix where, of course, because the scale factor is k, then the formula or the matrix is going to be k0, 0, k. K represents the scale factor, and in this case they say that it's an enlargement of -2. So therefore my enlargement matrix is going to be -2, 0, 0, -2. And so therefore that matrix then will be multiplied by the points of A prime, B prime, C prime. Why not A, B, and C? Because after A, B, and C was reflected, then followed was the enlargement. So I'm going to be enlarging the blue triangle instead. So I'm going to be using the points of the blue triangle, which is in fact A prime, B prime, C prime. So that's going to be 2, -3, -3, -4, and 0, -1. And so basically what we're doing is that we're basically doubling the points. So that's what we're really doing. Of course, the correct way is to say row by column, row by column, row by column. But it's really doubling that we're doubling the value. So what this means is then -2 multiplied by 2 is -4. -2 down here multiplied by -3 is +6. Then we go back at the top here, we see -2 multiplied by -3 is +6. And so -2 down at the bottom multiplied by -4 is +8. And of course, finally, then we have -2 times 0 is in fact 0. And -2 multiplied by -1 is +2. And so the values, the coordinate values that are in pink here will represent the vertices of the image after the enlargement. So let's plot those points. -4, 6. So that's -4 to my left. That's 1, 2, 3, 4. And up 6, 1, 2, 3, 4, 5, 6. So that's going to be my A second prime. And so B is going to be 6, 8. So that's going to be 6 into the right, 6 to the right because it's positive. So that's 1, 2, 3, 4, 5, 6. And up 8. 1, 2, 3, 4, 5, 6, 7, 8. That is right here. That's my B double prime. That is after the enlargement of the blue triangle. And C, then we have 0, 2. So that's going to be 0 again in the center here. And the second number represents how far I go up or down. It's +2, so it's 1, 2. That is right here. And that's going to be my C double prime. So of course I'm going to be connecting then, say here, these shapes, these vertices. Whoops. Pardon me. Got a little bit shaky there, guys. So here I'm going to be connecting this with, say here, this. A little shaky. Here. Then I'm going to come here. Okay. I think I kind of prefer drawing this one over. It's a little shaky. I'm going to try to keep it as straight as possible. It's not working out, guys. It's a little better. Alright, that is it, guys. Beautiful. Alright. So without a ruler, guys, that is going to be our completed diagram. And we went through a lot of stuff here as it relates to transformation. So of course I know that you guys are going to want a full tutorial on whole reflection aspect. I'm going to be walking you through the whole process of that reflection matrix, how to use row by column, as well as using the shortcut for reflection. So definitely stay tuned and do not forget to share the video out to other math students before this video is posted. All right, thank you so much, guys, for watching. Please continue. We're gonna get into, say here, the final phase here. Now it did ask us a bonus question. It's a bonus question here. What is the name given to the combined transformation of a reflection followed by a translation? We did in fact went through this. One of my group of students, they did in fact went through this. It is called a glide transformation or a glide reflection. So if you did not know that, guys, then whenever an object is reflected, then it's translated, or if it's translated, then it's reflected. It's called a glide transformation or a specifically glide reflection. So didn't require much calculation there, just a little bonus question to get an extra mark then. All right, and so then for question 4 now, we're going to go back to fundamentals. We're going to be looking at, say here, variation, a topic that I repetitively in fact did with the students. I do have 2 full tutorial videos on direct and indirect variation on the channel, both using the tables as well as using worded problems. So do definitely go ahead and check this video out. Of course, you can check the playlists in the description the fundamental playlist in the description box and right here pinned in the suggestion at the top and right hand corner here. Alright then, so for question 4, we're looking at two variables x and y are related such that y varies inversely as the square root of x, and so very often students are continually being caught by this little change at the end. It is the part where they say that it can be varies inversely as the square root of a term, or the square of a term, or the cube of a term. You guys have to be able to slow down and read the question, that upon writing the formula you can make the necessary adjustments between the relationship of the variables. So let's get onto that, say over here. So here's the table that I've redrawn for us here. And so we are seeing here that y varies inversely as the square root of x. Let us first write down the very basic form of inverse variation. And we know that the very first form is that y is equal to k divided by x. I saw many different types of equations on many papers that I've marked. I've seen k is equal to x times y, k is equal to y over x, k is equal to x over y, just different variation. And most times when you find a student not having just this very basic knowledge that I'm giving you here, it is simply because there's many more time spent on memorizing the topic as opposed to practicing the questions. So this here, y equal kx, is the basic form of an inverse variation, but there's an adjustment to the formula. It did say that y varies inversely as the square root of x. I saw persons also writing, say here, x to the power of 2. That is lacking in knowledge of what is the square root sign and the square sign. Again, remember guys, if you're watching this video and you're an advanced student, my videos are specifically geared towards preparing Caribbean students for exams that are coming up yearly. That is in fact in January and of course in May. But of course, if you're an advanced student, you most likely would not be watching this video. Alright, so now that we end up with the correct formula here, let's put it in blue because that's the one that we really want to work with here. We are given a table of values and then so forth that we should in fact find the values of r and f. Now we did in fact get 1 mark for creating this formula, and of course we need to find the values of r and f. But we all know, and we should know based on my previous tutorial lesson, that you cannot find any unknown values in the table or in the question without the value of, say here, k. So then we're going to go ahead then and write our formula. Y is equal to k divided by, say here, the square root of x. And we have to look on the table now and see which column has been completed. Of course, this column here 49 and r is not completed. This column here f and 16 is not completed, but this column here 25 and 3 is completed. So therefore then we can look across and say here x is 25 and y is 3. So we can go ahead then and say, all right, 3 is equal to, say here, k divided by the square root of 25. And so therefore then easily then 3 is equal to k divided by, say here, 5. And so easily then we have said this repeatedly, we can cross multiply or just simply remember that when the unknown is at the top, when the unknown is in the denominator, we're going to simply multiply 3 by 5 here. So 3 by 5, therefore k easily works out to be 15. Now again, of course, as you're working variation question, we've said this repeatedly, you've always got to rewrite your formula if you're required to find more unknown variables. So y is equal to k divided by the square root of x. Always write your formula to start a new question. So therefore then we're looking at column 2 where x is 49, but the variable y is now being represented by r. So since y is being represented by r is then equal to k, which we just calculated to be 15, divided by the square root of, say here, x, which in this case here is going to be 49. So this is equal then that r is equal to 15 over 7. If you want to go ahead and say here write the decimal form for the answer, that is also fine. So therefore r would have been equal then to say here 15 divided by 7, and that's equal to 2.14. So you can write the decimal form or you can write the fraction form. And so therefore then we have the final variable here to calculate, and that is in fact going to be that y is equal to k divided by the square root of x. And in this case, in the third column here, we have that x is f. X is now represented by f and y is 16. So y is 16, and so here k we already know is 15, and x is now being represented by f, so it becomes the square root, pardon me, it's going to be 15 divided by the square root of, say here, f. Now what happens when the unknown variable is in the denominator? We're going to do a swap. So we're going to bring the square root of f to the top, and then that's going to be equal to 15, and we're going to bring the 16 at the bottom here. All right, and so therefore then, in order for us to find f, since f is being covered by the square root, we're therefore going to go ahead and square both sides. So we're going to go ahead and square the square root of f, and we're going to go ahead and square the 15 over 16, so that the square root will be cancelled by the square. Therefore, beautifully, we have that f is equal to, if you want to go ahead and 15 divided by 16, get the decimal and then square the decimal. I'm just going to stick with fractions for now. I'm going to have 225 all over 256, and so if you divide that, you're going to get, I believe, 0.93, something of that sort. Alright, so but I kind of prefer fraction. If it was just me alone, I would just leave the answer as 15 over 7, and I would therefore go ahead and leave the answer as 225 over 256. All right, so that is how you approach that variation question. It wasn't a challenging one at that. I've given much more challenging questions than that one, but nevertheless here I do hope that you students are following to the T. All right, let us continue then on down to, say here, this question at the bottom. It says here that we should use, okay, we already found K, R, and F. Beautiful. So we're going to be moving on to the final question for this exam paper, question 5. And as I had mentioned before, guys, there were 2 questions on the paper. I think it was in fact question 1 that was on the previous video, and so here question 5 also was on the previous video. I had to change it up a little bit because there were different groups of students that would have seen that paper and its solution, so I wanted to keep the integrity of the exam pure. Let's wrap this up then by finishing here with question 5. The points T minus 2, 4, Q 3, negative 2, and R negative 1, negative 1 are distinct points on the Cartesian plane. Optional. We should determine the following: slope of QR, length of TR, determine the equation of QR, find the midpoint of TQ, and of course determine the equation of the line that is in fact perpendicular and passing through the midpoint of TQ. Sounds very complicated. Alright, now why did I put the word optional here? All the students were directed that if you want to go on the graph and plot, you won't get any extra marks for the plot, but if you want to use any graphical method to get to your answer, I also opened that option. So if you wanted to calculate the slope of the line by using rise over run, you could have used your graph. If you wanted to plot the points T and R and use a ruler to measure TR, then I would have allowed you and given you the full marks if you did all of that. But many students did not use the graphical approach because the optional the option of using the graph or not using the graph was given. All right, but for me, this question doesn't require a graph. There are basic formulas that, as I've repeatedly said to my students, if you do not remember the formula for these particular types of questions, you're going to find that your efforts are going to be quite futile. So therefore, then it is a must for you to remember the formula. You've got to take some time out, spend some time, and regurgitate the formula. Not only by practicing and doing practice questions, but you've got to sit down in a group, in a pair, and you've got to have a formula practice session. All right? Formula practice session. Wonderful. So therefore then, the first question here is to find the slope of QR. Now I did in fact went ahead and place my points around here. So I have them ready already for you here. So the slope of QR, slope meaning gradient, we have a gradient formula which is y2 minus y1 over x2 minus x1. And so therefore then easily you're going to find here that since we're looking at QR, I'm going to call Q my x1 and call Q my x1 and my y1, and I'm going to call R my x2 and my y2. Again, I also found a few students not being able to label the points correctly. I found students writing x1 and x2 and y1 and y2. Remember that when you're given a point, ladies and gentlemen, boys and girls, a point has a x value and a y value. Every single point has to have a x and a y. Now, since we've labeled the points here, we can just simply go ahead then and say y2 according to the label is -1. And I'm going to take away here y1, which is in fact -2, so that's -1. Take away -2. And that's going to be divided by, say here, x2, which is -1. Take away, say here, x1, which is 3. So now our integers come into play here. These two negatives gives a positive, so that's -1. Say here, +2. -1 plus 2 is in fact 1. And that would be divided by, say here, -1 take away 3 is -4. So basically, we end up with an answer. Our gradient here is -1/4. Okay, let's just write it a little bit better here. This is going to be -1/4 for our gradient. -1/4 or 1/-4. All right. Once again, then we're going to be moving on to say here length of TR. Of course, you need the length formula, which is the Pythagoras theorem using on the Cartesian coordinate system. It is in fact that length is equal to the square root of y2 y1 squared plus x2 minus x1 squared. And so therefore then, of course, we're looking at T and R. So I'm going to still keep R to be my x2 y2, but I'm just going to shift over here and I'm going to call this again over here my x1 y1. Please bear in mind that I've used two different color inks. So here I was using Q as my x1 y1 because I was looking for the slope of QR. I'm now changing my x1 y1 to a different point, which is T here, -2 minus 2, 4. All right, so let's go ahead into the formula. It says y2 minus y1, so it's going to be y2, which in this case is -1, take away y1, so that's -2. It's going to be the square root of -2 minus Pardon me, let's double check that again. It's going to be minus 1, pardon me. So it's minus 1. Take away 4 squared plus x2, which is negative 1. Take away x1, which is negative 2. And all of that then will be squared. You've just got to take your time, guys, when you're labeling your points, and that's where the challenge comes in. One wrong sign is all it takes to get this question incorrect. So here then we end up with, say here, negative 1, take away 4, that's negative 5 in bracket, and remember to square it. We talked about this when we were doing quadratic equation. And then of course we have these two negatives inside becomes a positive, so negative 1 plus 2 is 1 squared. So this then be extended to the square of negative 5 is positive 25 and the square of 1 is 1. So we end up with root 26 units. If you want to go ahead and write down the square root of 26, that's also fine. But I'm going to go ahead and keep the answer as the root of 26. But again, see here that we want to go ahead and do that. Square root of 26, we're going to get 4 or 5.09 as our units in terms of a decimal. All right. Coming down to the end, ladies and gentlemen, the equation of QR. Please note that the equation of any line is in fact going to be y equal mx plus c. Alright, that's the equation of any line. Please review my tutorial video. I think you'll find this in part 2 of my coordinate geometry playlist. And so then the gradient of QR, which we had already calculated up here, because we already calculated slope of QR, which is the gradient of QR, to be minus a quarter. So down here I already know that m is in fact minus 1 over 4. I know that for certain. That's going to be multiplied by, say here then, x. So looking at Q and R, we can either use the bracket Q or the bracket R. Is up to you. I'm going to be using the bracket R just for the purpose of exercising. Alright, I'm going to be exercising. Normally, I would just recommend that you use the first bracket. Let us just use the second bracket and see what happens here. We're going to get the same answer. So therefore, we're going to be using minus 1 as our y2 and minus 1 as our x2 as well. So then we're going to go ahead and say here x1, x here is minus 1, and of course y here is also minus 1. So therefore then that's going to be plus c. Right, so now that that is plus c, then we're looking at minus 1 is equal to, say here, minus 1. Let us see here, minus 1 multiplied by minus 1 is positive 1 over 4. We could go ahead and multiply everything by 4. That's also fine as well. But it's going to be the same thing here. Minus 1 multiplied by minus 1 is positive 1 over 4 plus c. We're going to then transpose the 4, the quarter, over here. So we're going to have minus 1 over 4. Then we can go ahead and find the LCM. Pardon me here, guys. So we're going to put this minus 1 over 1. The LCM here is going to be 4. So 1 into 4 goes 4 times. And 4 into 4 goes 1 time. So negative 1 multiplied by 4 is negative 4. And 1 multiplied by 1 is negative 1. So we end up with here, say C is equal to negative 5 over 4. So now that we have, say here, the value of C, we can conclude that our equation then is y equal negative a quarter x minus 5 over 4, and this is writing it in its general form. We can write it in its standard form in a future tutorial. All right, and then we're going to be looking at finally, well, not finally, we have the midpoint here. And so the midpoint, which is capital M, is actually equal to, say here, x1 plus x2 over 2, and so forth, comma, that we have y1 plus y2 over 2. Again, we're going to be using, say here, the points T and Q. So here, if I remember correctly, that T is in fact negative 2, 4. So that's negative 2, 4. And Q here is, say, 3, negative 2. 3, negative 2. Kind of always like rewriting my points and then relabeling again. So I'm going to have x1, y1, x2, y2. So therefore then, the midpoint is equal to, say here, x1, which is negative 2, plus x2, which is 3, over 2, and that's going to be comma, y1, which is 4, plus y2, which is negative 2, and that is all over 2. So therefore then, minus 2 plus 3 is 1 over 2, comma, say here, 4 plus negative 2 is 2 over 2. And so finally then, we can have a midpoint value of a half, comma, 1. All right, let's put a box around this, because I think in the next question we're going to be utilizing this point here. All right, and that's the midpoint. And then finally then, to bring us to the end of this video, we're going to be looking at finding the equation of the line perpendicular to QR and passing through the midpoint TQ. Try to make the question a little tricky here, just in case I have a student that is trying to perfect my exam. I want to throw them off a little bit with this one. This is not very usual, but let's see what happens for this one here. Once again, the equation is in fact y equal mx plus c. Now for this case here, we need to calculate what is known as the perpendicular gradient. And so the perpendicular gradient, which I label as m2, is going to be minus 1 divided by, say here, the first gradient. So we know right away that m2 is going to be equal to negative 1 divided by m1, which is in fact negative a quarter. Bear in mind, guys, if you did not know that the perpendicular gradient is minus 1 divided by m1, then you can visit part 3 of my coordinate geometry video. We went through in details what that topic was about. So therefore then, m2 easily is going to be minus 1 multiplied by the reciprocal of negative 1 over 4. That's going to be 4 over negative 1. And of course, by simplification here, m2 is equal to negative 1 times 4 is negative 4 over negative 1, which is positive 4. So therefore then, you're going to find here that the perpendicular gradient to that line is m2. But bear in mind that we're looking for the equation of the line perpendicular to QR, but the point of intersection between both lines are going to be through the midpoint of TQ, which we already labeled here as half and 1. And remember, so the half is going to be x and the 1 is going to be y. So therefore then we end up with y being 1 here, and we know that the perpendicular gradient now is 4, and of course x is therefore going to be a half. That's the x value here, that's a half, and that's going to be plus c. Easily then, 1 is equal to 4 times a half is 2, so half of 4 is 2 plus c. Carry this 2 over here, we end up with 1 take away 2 is equal to c. Therefore negative 1 is equal to c. And so by conclusion then, the equation of this line is y equal the perpendicular gradient 4 times x minus the new value of c here, which is 1. And that completes not just this particular question, but it completes our examination. All right, so I really do hope that you have now once again gotten all the clarity you need on this particular paper. The next exam coming up is going to have a little bit more twist, but it's good, guys, that you can actually use this paper as a guide in terms of preparing yourself for certain questions that may come. Now, I do have a surprise for you. These questions are in fact questions that I took in parts and kind of adjust from the year 2006, but I kind of restructured the question and added a few more as well. So of course, guys, thank you so much for spending the time here with me. We've been here but a little bit over an hour and 45 minutes, and I want to thank you guys for staying with me on this channel. Do not forget to hit the subscribe button below, turn on your post notification bell for weekly posts, daily posts. In fact, I'm going to be posting videos almost every day leading up to exam. We're going to be having lots of exams review, lots of in-between topics, sometimes some live classes, and I have great things coming up in the summer. My new book is coming out very soon, Fast Track Learning to CSEC Math. So stay tuned for that. Many great things are coming up on the channel. Alright, so do take care until next time. My name is Akin, your math instructor. Keep on practicing. Develop your mathematical skills with precision and accuracy. Take care until then. Bye-bye.